Okay, let's give you guys some practice now. So sketch this graph in polar form, from 0 to 2 pi. So ultimately you want to sketch this graph here in polar form. But in order for you to sketch it in polar form, you need to keep track of the radius. So you need to keep track of the radius. So you want to sketch this first. Ultimately you want to sketch this in polar form. But in order for you to do it in polar form, you need to keep track of the radius. So sketch this graph first. Once you've got this, then you can sketch your graph in polar form. So, well, anyway, do whatever you want, sketch it in polar form. So press pause and have a go. Okay, so to do this, somehow we need to keep track of the radius as theta varies. So we need this before we can sketch it in our polar form. So let's try and keep track of this now. We are now going to draw this graph here. So use whichever method you want, but you could do this. Start out with your cosine. Well, you use whichever method you want. So I'm going to do it this way. This is your cosine of theta here. So we can say we can imagine this as being like this. We can imagine it as being like this. This is our original function, cos of x. We are trying to understand this thing here. So your next transformation would be this bit here. So your next transformation would be f of 3x. So that would then give you cos 3x. So that would then normally it's 2 pi here, but because of this 3, it squeezes everything in by a factor of 3. So it's going to be something like this. So normally 2 pi is here, cut up into 3 equal pieces because of this. So one cycle would be this. One cycle would be this. You start here at 1, and then you start here at 1, and then this is 1 cycle, 2 cycles, 3 cycles, and then now you need to change the magnitude. So your next transformation would be this: 2f of 3x. So that would then give you 2 cos 3x. So this graph here would then become this. So normally 2 pi, you cut up into 3 pieces like we did over here, but then instead of the magnitude being 1, because of this, now the magnitude is 2. So now it's like this. Oops. Now it's like this. 1 cycle, and then 2 cycles, and so on. So this here would be negative 2. Well, basically, use whichever method you want. So this thing here will then become this. So this is so it will then become this here. So from here to here, it's 2 pi. But then because of this transformation, we split it into 3 equal parts. So 1, 2, 3. So this from here to here would be this whole length, which is 2 pi, cut out into 3 equal parts. So this bit here is 2 pi over 3, because we would get the 2 pi divided into 3 equal parts. This bit here will be this length times 2. So it would be 2 pi over 3 times 2. So that would be 4 pi over 3. So this thing here will be 4 pi over 3. And then cut this up. So it would be this length divided by 2. So it would be this divided by 2, which will be 2 pi over 6. And then if you cut in half, this point here will be this, you cutting in half. Hang on, let me think, sorry. So hang on, let me think. So from here to here, it's 2 pi over 6. So this point here would be you getting this and then cutting in half. So that would be 2 pi over 6 cut in half. So that would be 2 pi over 12. This point here will be 2 pi over 12. And then if you cut in half again, then this will be, get this, divided by 2, but we're going to cancel these out. So it would be pi over 12. It would be pi over 12, and and then let me think. Oh yeah, so here you got over 3. The denominator here is 6. The denominator here is 3. The denominator here is 12. Work all in terms of 12. So looking at this here, times top and bottom by 2. You see this point here will then be 4 pi over 12. Work all in terms of 12. This whole graph here will then become this. It's quite messy, bear with me. So work all in terms of 12. Look at this, pi over 12, 2 pi over 12. Everything is in terms of pi over 12. So if you look at this point here, pi over. So remember, originally our radius was this, 2 cos 3 theta. Now if you put pi over 12 into here, that would be pi over 12 times 3. That would be 3 pi over 12. So let's simplify this. This simplifies to pi over 4. Well, remember, cos of pi, this bit here, cos of pi over 4 is cos of pi over 4 is really 45 degrees. That's like 1 pi over 4 here. So if this is 1, this is 1, then this must be square root of 2. So this here, so cos of pi over 4 is 1 over root 2. Is 1 over root 2. Another way of looking at this is times top and bottom by square root of 2. That will give you root 2 over 2. There are two ways of looking at pi over 4. Well, and then so this bit here will be this, and then when you times 2, it will just give you the square root of 2. That's why when it's pi over 12, it will give you square root of 2. Okay, so it looks messy at the moment. It looks messy at the moment. So just bear with me on this. If you're doing this by yourself, it will look messy. But because I'm presenting to you, I'm going to use a graph plotter, and it looks much neater in this way. So hang on. So looking at this only, looking at this one cycle only, it will then give you this. Hang on. Looking at this one cycle only, so this is one cycle here. This here is one cycle. So this bit here is this bit here. Okay. So when you're sketching, it's going to be messy like this. But because I'm illustrating to you, I'm going to cheat and use a graph plotter and plot this, so it's easier for me to communicate with you. And then we can now make use of this to plot this thing here. I will continue in the next video.